A very good evening to all the 11th standard children of St. John's. In the previous maths class, we have done a few problems based on the concept of distance between a point and a straight line and distance between parallel lines. And also we found out the image of a point about a straight line. So more often we are doing problems related with the straight line and points, right? Now we are moving to the next concept called pair of straight lines. So far we have discussed about a single straight line. Now the heading is pair of straight lines. The meaning is, let a1x plus b1y plus c1 equal to 0. This is called linear equation because the degree is 1. So any linear equation, definitely it represents a straight line. So let this be a straight line, and a2x plus b2y plus c2 equal to 0 be the second straight line. So these two are two straight lines. Then the combination of these two, that is a multiplication, the product of these two, that is first line into second line equal to 0. This is called the pair of straight lines. So we are combining two straight lines together and saying it in a single equation, then that is called pair of straight lines. So pair of straight lines means in that equation we have two straight lines. That is the meaning. Once again I will repeat. This is first straight line and this is second straight line. These are separate straight lines. When we combine these two like this equation is called pair of straight lines. So pair of straight lines is an equation which will contain two straight lines in it. So when I multiply this, I will be getting some x square term, xy term, x term, again xy term, y square term, y term, and then x term, y term, constant term. So when we multiply, we are going to get an equation of second degree. Yes or no? Second degree equation. Why I am telling second degree? Because x into x, x square, the degree will be 2. So when we multiply, definitely we will get second degree equation. That second degree equation will be called as a pair of straight line because it contains two straight lines in it. So this is the definition of pair of straight lines. Now next we will see the heading, angle between pair of straight lines. When I say pair of straight lines, we are talking about two lines. Definitely there will be an angle between them. So that is given by this formula. Tan theta is equal to 2 times root of h square minus ab divided by a plus b, where the equation will start like this. That is, the pair of equation will be starting like this: ax square plus 2hxy plus by square is equal to 0. Or to be more relevant, to be more precise, what we have to say is, in fact we will have second degree equation of this format: ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. So we will clearly get this type of equation when we multiply these two brackets, because x into x, x square term we will be having. When I take this x with y, xy term will be coming. Then x with this constant, x term will be coming, so that is written here. When we take y with this xy term, already written, y into y, y square term will be there, y into constant, y term will be there, that will come into fy, and constant c1 into c2 will be the constant term. So when we multiply two separate straight lines equations, we will be getting an equation of this format. Definitely this is called what? This is called second degree equation because degree is 2, and this represents what? Pair of straight lines. Not always, sometimes, because it is not compulsory that all second degree equation means it is a combination of two straight lines. No, it may be a curve also. It may be a combination of two straight lines also. Not always, but sometimes. But if we take this alone, ax square plus 2hxy plus by square equal to 0 means it is a pair of straight line which passes through origin. This is a pair of straight line which passes through origin. This is nothing but general equation of pair of straight line or general second degree equation. Keep this in your mind. When we multiply these two, you will be getting an equation of this format. Definitely this will contain two lines. Again I am telling, not always, sometimes. It is a combination of two straight lines. If that is the case, then definitely there will be angle between those two straight lines, which is given by this formula. Tan theta is equal to modulus of 2 times root of h square minus ab by a plus b, where h is nothing but here. So 2h is there now. From that we can calculate h, substituting that h here, and a and b are nothing but coefficient of x square and coefficient of y square. So when we know h, a, b, we can calculate the angle between the two straight lines. Hope you will understand. Next, condition for parallel lines. Suppose if this is the equation, and if the two lines present in it are parallel, then that can be checked or verified with this condition. If h square minus ab equal to 0, that is this value, then the lines are said to be parallel. Again I will repeat, what are these two? This is a straight line and this is another. This is one straight line, this is another straight line. We are multiplying those two, putting only one equal to 0. So this is nothing. When we multiply these two equations, we will be getting an equation of this format, which is called a second degree equation. It may sometimes represent a pair of straight lines. It may be sometimes the combination of two straight lines, may not be also. But if it represents a pair of straight line, then the angle between the lines is given by this formula. Suppose if the two lines in this are parallel, then the condition is h square minus ab will be equal to 0. Hope you will understand. We'll for the next concept. The next one is condition for perpendicular lines. Again, if we are having a second degree equation, so even you can refer this equation also, general form of pair of straight lines. So this is the general format: ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. This is called what? General form of pair of straight lines. So what are all the terms it is having? X square term, xy term, y square term, x term, y term, constant term. So 6 different terms: x square, xy term, y square term, x term, y term, and constant terms. These are the 6 different terms which will present in general second degree equation, which may be a pair of straight lines. So I said this equation represents pair of straight line, not always but sometimes. But if it is a pair of straight line, then if those two lines are perpendicular, then the condition is given like this: a plus b equal to 0. That is, the coefficient of x square and the coefficient of y square, if we add them, the answer should be 0. If the answer is 0, then we can directly say the two lines are perpendicular. Next important thing, condition for second degree equation to represent a pair of straight line is, now just before I said this is a second degree equation which may represent a pair of straight line or even may not be. But if this condition is satisfied, then definitely this will represent a pair of straight line. So this will not always represent a pair of straight line. If it satisfies this condition, definitely this equation will represent a pair of straight line. So what is the condition for a second degree equation to represent a pair of straight line? Means the condition is given by ABC plus 2FGH minus AF square minus BG square minus CH square equal to 0. If this value becomes 0, I can boldly say that this equation definitely will represent a pair of straight line. The meaning is definitely it is a combination of two straight lines. If not, it is not a pair of straight line, it may be a curve. Hope you will understand the basic concept here. This is called second degree equation. When this will represent a pair of straight line, if this condition is satisfied. This condition is having 5 terms: ABC plus 2FGH minus AF square minus BG square minus CH square should be equal to 0. If it is 0, definitely this equation represents a pair of straight line. So this is the condition for second degree equation to represent a pair of straight line. The next one, if two straight lines represented by this, that is pair of straight line, if they are pair of straight lines, then the distance between them, suppose this equation represents a pair of straight line, then definitely it contains how many lines in it? Two straight lines. Definitely there will be a distance between those two lines. That distance between the two lines is given by this formula, 2 times root of g square minus ac by a into a plus b. Even if you see this formula, all the terms a, b, c, f, g, h are all taken from this equation, a, b, c, f, g, h. So everything is taken from this equation only. Here also, for finding the distance, 2 times root of g square minus ac, g square, this is a, c, by a into a plus b. A and b are all present in this equation only. So from this we can find out the distance, as well as we can check whether it is pair of straight line or not. So it is important to learn the formulas which was given to you. This is the formula for condition for a second degree equation to represent a pair of straight line. This is the formula to calculate the distance between the lines. Now with all these concepts we will see few problems. Sum number 30. Find the combined equation of the straight lines whose separate equations are, this is first one and this is the second straight line. The question is very simple. We need to combine the equations, these two. These two are separate equations of straight line. This is separate straight line. This is a separate straight line. What they are asking? They are asking the combined equations. Combine these two and find a single equation. So what we have to do? First I am writing the separate equations. The combined equation means I have to multiply these two, combine these two. So this is in first bracket, this is in second bracket, and only 1 equal to 0. So combining the two straight lines, just multiply the brackets term by term. Take x and multiply with the 3, so you will get first 3. Take minus 2y with 3, so that you will be getting the next 3. Minus 3 with the 3, another 3 terms. So 9 terms you will be having. Arrange it in order. First x square. Here xy term is there, no? This plus xy and minus 2xy. Combining these two, we are getting minus xy. Similarly, x term is combined with, if any other x term is there, we have to combine. So 5x minus 3x, 2x. Right. Then y square minus 2y square. Y term minus 10y minus 3y minus 13y. Minus 15 is equal to 0. So it is a very simple sum. Just combine the two equations, multiply and write the answer. Arrange it. That's all. Problem number 31. Show that 4x square plus 4xy plus y square minus 6x minus 3y minus 4 equal to 0. So if we see, we can say that this is a second degree equation because it starts from square, x square. So degree is 2. Show that this second degree equation represents a pair of parallel lines. So immediately we should go for the theoretical part. What is the theoretical part that we have seen? If an equation represents a pair of straight line, and if those lines are parallel, then the condition is given by h square minus ab should be equal to 0. That is the condition that we know. H square minus ab should be equal to 0. Now first we will write the given equation here. Now clearly we will compare this with the general second degree equation. This is called the general second degree equation. Ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. Six various terms are present here. X square, xy, y square, x term, y term, constant term. Right? So this is the general second degree equation that we know. This is the equation which is given to us. So comparing these two equations, I can say a equal to 4, right? Because x square coefficient is called a. Here 4. So a is 4. xy coefficient is called 2h. So 4 is written as 2h. From that h is 2. Y square term comparing b is equal to 1. Comparing x term, 2g equal to minus 6, g is equal to minus 3, cancelling with 2 table. Comparing y term coefficient is generally called 2f. So here it is minus 3. So 2f is equal to minus 3. F means minus 3 by 2. So we should know how to compare these two and write all these things. What are the things that we have written? Finally, there was a constant present and that is called c. So c is equal to minus 4. So how many values that we wrote? 1, 2, 3, 4, 5, 6 values. What are they? A, H, B, or even I can say A, B, C, F, G, H. Totally 6 values I have to find by comparing these two. What are the 6 values? A, B, C, F, G, H. So just comparing, we are writing all these things. Now, I want to show that this pair of lines are parallel. So what is the condition for parallel? H square minus AB. This value should become 0. We will check it. H square, H value is 2, so 2 square minus A into B, 4 into 1. So 4 minus 4, the value is 0. Since this value becomes 0, which value? H square minus AB becomes 0. We can say that the given equation, it represents a pair of parallel lines. Therefore, the given equation means this equation represents a pair of parallel lines. Why? Because it satisfies the condition h square minus ab equal to 0. Again, it is a simple problem. Only we should know how to compare these two and write all the values. Going to the next sum. Problem number 32. Show that second degree equation is given 2x square plus 3xy minus 2y square plus 3x plus y plus 1 equal to 0. Show that this equation represents a pair of perpendicular lines. If we see the previous problem, they have asked us to show that it is a pair of parallel lines. Here they are asking us to prove that this is a pair of perpendicular lines. So what is the condition for perpendicularity of two lines in pair of straight line? Yes, the a plus b equal to 0. If we add a and b, the answer should be 0. Then we can call those lines are perpendicular. So again, just writing the given equation first and the general second degree equation next. So writing these two, this is given to us. This is called general second degree equation. Ax square plus 2hxy plus by square plus 2gx plus 2fy plus constant term equal to 0. So just compare as we did in the previous sum. X square, so a is equal to 2. In place of 2h, 3 is present. 2h is 3, h is 3 by 2. Y square comparing, b is equal to minus 2. Comparing x term, 2g equal to 3, g is 3 by 2. 2f equal to 1, f 1 by 2. Constant term is 1, so c is equal to 1. So comparing these two equations, writing 6 values. Now just add a and b. Even in this sum we need not find everything. Even if we write a and b, that is also enough, because that is what we want here. A plus b, 2 minus 2. Again answer is 0. Since a plus b is 0, what can we say? The given equation, that is this equation, represents a pair of perpendicular lines. Therefore the pair of lines are perpendicular. Problem number 33. Prove that the equation 2x square minus xy minus 3y square minus 6x plus 19y minus 20 equal to 0. Clearly this is a second degree equation. Show that it represents a pair of intersecting lines. Show further that the angle between them is tan inverse phi. So we need to prove that this represents a pair of lines. Intersecting, if we prove, intersecting will be followed, because only when the lines are intersecting we can find the angle. If the lines do not intersect, we cannot find the angle, yes or no? So what our aim is to prove? First our aim is to prove that the second degree equation represents a pair of lines. Next we need to find the angle, and the answer is tan inverse phi we have to prove. First we are writing the given second degree equation. As usual, we will write the general second degree equation, compare these two equations and find out the values for a, b, c, f, g, h. Yes or no? C value is here. The C value is what? Minus 20, because the constant term is minus 20. A is 2, 2h equal to minus 1, h is minus 1 by 2, b is minus 3. Comparing x term, 2g is minus 6, g is minus 3. 2f value is 19, f value 19 by 2, constant value is minus 20. So what is the first step? Comparing this second degree and the general second degree, we found out a, b, c, f, g, h. What we need to prove? This equation represents a pair of lines, pair of straight lines. What is the condition for a second degree to represent a pair of straight line? ABC plus 2FGH minus AF square minus BG square minus CH square equal to 0, right? So we are going to write that condition and verify whether that answer becomes 0 or not. That is our next line. So writing the condition for second degree to represent a pair of straight lines, this is the condition, right? ABC plus 2FGH minus A into F square minus B into G square minus C into H square. The value should become 0. So our aim is to substitute the values A, B, C. What are the values that we wrote? No, A, B, C. Just substitute F, G, H, F, G, H, A, F square minus B. B is negative, so plus B, G square minus C, H square. C is negative, so it becomes plus C, H square. Simplifying this, I think I need not explain the simplifications because you know multiplication, addition, subtraction and all you should know. So just simplify the numbers, see whether it is right. By simplifying, we are getting the answer as 0. So this is what we want. This condition becomes 0. So since it becomes 0, what we will say? Therefore, the given equation represents pair of straight lines. So first part we have proved, yes, the given second degree equation is nothing but a pair of straight lines. What is the second condition? Second part that we have to prove, the angle is tan inverse phi. So directly we will write the formula, angle between the pair of straight lines. What formula we have studied? Tan theta is equal to modulus of 2 times root of h square minus ab by a plus b. All the values we know already in the first beginning itself. H value we know, a value we know, b value we know. Just substitute that 2. H value is 1 by 2. So h value is actually minus 1 by 2. When we square that, 1 by 4. What is AB? A is 2, B is minus 3. Minus 6 will come. Another minus is there, so plus 6. A plus B. A is 2, B is minus 3. 2 minus 3 minus 1. Cross multiply. 24 plus 1, 25 by 4 by minus 1. Taking square root. 25 becomes 5. 4 becomes 2. 2 cancel. 5 by minus 1 minus 5. But modulus is there, so we will write as 5. Tan theta is equal to 5 and theta is equal to tan inverse 5. This is what we needed to prove in the second part. This is what they asked us to prove and we got the same answer. What is the angle now? Angle is given by tan inverse 5. Hope you will understand. Going to the next sum. Problem number 34. Question number 34. Find the equation of pair of straight lines passing through the point 1, 3 and perpendicular to the lines this and this. What is the meaning of this question? We need to find the equation of pair of straight lines, which means we have to find a second degree equation which passes through this point. The pair of lines passes through 1, 3 and pair of straight lines means we will have two lines. The one is perpendicular to this line and the other one is perpendicular to this line. That is what the given question is. So first what we are going to do is, any line which is perpendicular to this straight line, any line perpendicular to 2x minus 3y plus 1 equal to 0 is given by, even in the previous class we have discussed about this, how to write a perpendicular line equation. Three procedures. What are they? First, interchange the numbers. So 3 will come here, 2 will go there, right? So 3x, 2y. Second, change the symbol of y. Y is having minus symbol, so that should be changed to plus. Procedure number 3, change the constant term. Plus 1 is there, you take it out and put a new constant plus k. Again I repeat, first interchange the numbers 3x, 2y. Change the symbol of y, it becomes plus. Change the constant term. So what is this equation? This is a straight line which will be perpendicular to this. Yes or no? But the pair of straight lines pass through 1, 3. Therefore this will also passes through the point 1, 3. So what is the meaning? Put x equal to 1, y is equal to 3. So 3 plus 6 plus k, which is 9, will go to other side and becomes k value. K value is minus 9. What we will do immediately, substitute k value in this equation. So 3x plus 2y in place of k minus 9 equal to 0. What is this? This is one separate equation of a straight line. What we need? We need equation of pair of straight lines. Pair of straight lines means how many? Two straight lines, out of which we found out first equation. How to find the second equation? Using this, because second line is perpendicular to this. So again we will start, any line perpendicular to this 5x plus y minus 3 equal to 0 is of the form. What is the first step? Change the coefficients. 1 will come to x, 5 will go to y. So 1x, 5y. Change the symbol of y. Plus means you put minus. So x minus 5y. Change the constant. Minus 3 is present. Take it out and use new constant. Plus L. There we have used k. So we are using some other letter here. Plus L equal to 0. Equation number 2. This also passes through which point? 1, 3. So this passes through 1, 3. Substitute x as 1 and take y as 3 in this second equation. It becomes like this. From that we are getting L value as 14. Here minus 14, other side plus 14. What we will do next? Substitute L value in second equation. Second equation gives x minus 5y plus in place of L 14 equal to 0. So what is this? Second separate equation. So this is first separate equation. This is second separate equation. What is our aim? To find a pair of straight line. So we have separate equations, this and this. Hence the separate equations are, this one is the first one and this is the second one. So we can now easily write the combined equation. Therefore the combined equation is how to do? Just multiplying these two. First writing this in one bracket, this in the second bracket, equal to 0. Multiplying, we are going to get the answer. Now see, combined equation is given by, this is the first separate equation, second separate equation equal to 0. You know how to multiply. First take 3x and multiply with all the 3 terms. So you will be getting first 3 terms. Take 2y, multiply with all the 3. So you will be getting the next 3. Take minus 9, multiply with all the 3. So next 3. Totally 9 terms you will be having. 3x square and xy term, we are having 2 terms. 2 xy terms here, right or not? Where are they? One is minus 15xy. Will combine with 2xy becomes minus 13xy. X term will combine. So 42 minus 9 becomes 33x. Minus 10y square is written here. X term. Then y term is 45y will combine with 28y. 28 plus 45, 73y minus 126 equal to 0. So simplifying, that's all. Multiplying and simplifying, we are getting a pair of straight line equation. This is the question that was asked to us. Find the equation of pair of straight line. This is the equation of pair of straight line. And problem number 35 will be continuing in the next video. So don't forget to see the continuation video.